Hi guys, the lesson that I'm about to teach you today is an extremely rare lesson lost to the world. It was taught to me by my teacher, Mr. Bajpayee, when we were discussing quadratic equations. And it dates all the way back to 900 AD, during the days of Sridharacharya. And the story was told to me by my teacher. He said Sridharacharya was trying to explain to his students that a rectangle is actually just a square with a missing corner, and how does that work? So he started off with breaking down a rectangle into a square and a rectangle. So he said, let's chop this rectangle off and do a square where this is a square, this whole thing, and this is a rectangle. Now, he said, let's apply some symmetry to this. He chopped off half of this section, so now this becomes b divided by 2, and he brought that missing section down here. Same thing, it's got b divided by 2, and this is x. So now if you look at the whole thing, this whole thing is a square with a missing corner, right? You've got the length of this whole thing is x plus b by 2. So the area of that whole big red square is that minus the missing corner. Now the side is b by 2. So it's a small square by b by 2 by b by 2. So then this whole thing is going to be b squared by 4. So as you can see, a rectangle that we started off with, the area of the rectangle it's basically a square with a missing corner. And how does that apply to our current world's quadratic equation mathematics? I will go over that real quickly. And the whole thing is so beautiful. It started with a rectangle with a missing corner and ended up with the most used theorem of today, which is the Sridharacharya's formula, which we all know is b squared minus 4ac by 2a plus minus. So how do we start there? So the equation that we just did was something like x squared plus bx. That's what we broke down into x plus b by 2 whole square minus b squared by 4. So this right here is the missing corner of the square that is x plus b by 2. So if we expand the same equation to, let's say, something we are all familiar with, ax squared plus bx plus c. Now we start breaking this apart, try to bring it into a familiar form that we already discussed. Okay, so now we know that this thing is starting to remind us of a square with a missing corner. So if we break this down further, this thing will become x plus b by 2a square minus the missing corner, b squared by 4a squared plus our c divided by a. Now starting to look very familiar to our formula, that is b squared minus 4ac by 2a. That is what we're familiar with when it comes to our Sridharacharya's formula, our quadratic equation roots. But it all really just started with a square, with a rectangle turning into a square with a missing corner. So if we carry on this thing further, it's going to start to look quite familiar. So x plus b by 2a whole square. Now we can break this apart and it's going to look like this. So you can see starting to come together. So we started with a equation, thought of it as a square with a missing corner. The process is called completing the square. And it's really important when learning quadratic equations. So now, Sridhar Acharya said, okay, if the whole thing has to be equal to 0, okay, what's the value? What's the value of x? So now, this thing starts to simplify. A doesn't matter anymore. So we break this apart. B by 2a whole square equals b squared minus 4ac by 4a squared. Now the whole thing, we're just going to remove our square. So this thing will turn into, which will be plus minus, because we're doing a square root of an unknown that we don't know, 4ac, and then 4a squared is literally just 2a. So now the next step ends up being x equals, we're going to bring the b by 2a on that side, b squared minus 4ac by 2a. Those are the roots of the quadratic equation, also known as SRD equation. Beautiful, isn't it?